Hey guys, let's begin. We've got a Hi Stack Bats, Mr. G, Amok, Candy Magic Knight, Hayes. Thank you for the host, Hayes. And Eshaktar. Welcome, guys. Yeah, tonight we're going to do Sprite multiplexing. It's quite a quite a heavily requested topic, so I thought it was about time we actually looked at it and did it. I tend not to use multiplexing very often, at least not general multiplexing anyway. So the last general multiplexer I wrote was probably in the first couple of weeks of .cosmos, so thanks for the host, Andy. I don't know why I'm not getting alerts for hosts, but maybe I need to open Muxy as well. Hang on. Keep that thing open. I've been doing this now almost 6 months, and I still don't get how to do it all. So, hi Stepz, hi Buzzley, welcome to the stream, guys. So first of all, we're going to talk about the different types of multiplexer. So I'm going to type some code as I talk about it as well, because I'm going to create some basic style code just for us to demonstrate some of these things. So the simplest type of multiplexer is what you've probably seen in games like Turrican for the big bosses, and those let me save this file somewhere. Those multiplexers are designed just to display a row of sprites in one location, and then another row of sprites directly underneath that row, and so on and so on. Probably the best example of that is in Creatures 2. There's a level in Creatures 2 where you've got the big creature in the middle. Sad that Twitch got rid of the extra chat rooms. Yeah, it was really useful actually. So it is a shame. Actually, we've got Creatures 2 in here, haven't we? No, we don't. Okay. So let me see if I can find a picture of that monster that I'm on about and demonstrate. It's usually quite easy to find. Oh, there's a. Well, let's not go with a video. Let's just go with a picture. Yeah, so it's kind of the easiest one to set up. Oh, it is. It's going to go into the video anyway. Let me just mute it. Skip through. So it's this guy here. Obviously, you can't get a sprite that big, so what they do is create rows of sprites for the multiplexing. So basically, there's an X and a Y position for the start, which will be around here somewhere, and then you display a row of 6 or 7 sprites or whatever. And then as soon as you've drawn those sprites and the raster has gone past the first line of sprites, you can begin setting up the positions for the next one. And it creates these nice huge monsters, and it's a really simple way of doing big enemy sprites like that. It's not much use beyond that. But that's I don't know what you'd call that. I don't know what the name of that kind of technique is called, but it's used quite often for big enemies. So what I'm going to do first, I'm going to demonstrate how you do that and why that works. It does glitch a little bit on the Ultimate. Yeah, that's because I think one of the rasters that turns the sprites on is just slightly mistimed. So okay, so let's start by just kind of setting up some interrupts in here. So first of all, we're gonna bank out all the memory. I do this every time. Probably don't need to do it for this, but I'm going to anyway. And then I'm going to enable the rasters. Like so that enables our rasters. I'm going to create a loop that we just jump to. However, before we actually, oops, that should be loop. We need to actually set a line up, so we'll just do it on line 0 for now, and I'll demonstrate why it's easy to do those effects. So we need to store our line, make sure we cancel out the upper bit, and then we'll create an IRQ. So this is just setting up a simple IRQ to do the work for us here, and return from the interrupt. I am going to save all the things as well, just in case we need them at some point, which we probably will. And then I'll do a quick test just to make sure that raster is actually happening. Transfer accumulator to Y. Oops. Okay, and then I'll indent in the middle here so you can see this is the actual raster code. So I'm just going to increment the border color here. I think that should be enough. Hang on. Yeah, okay, let's give that a quick run. So what we should see here is the border flash, but a fairly steady color, which we're not, and that's simply because you need to acknowledge your raster at the end. So the last thing you need to do in a raster is acknowledge it, or else it'll just keep looping. And there we go. So we've got a fairly steady. You can see the line at the top where it's doing it. So we've got a steady raster. So we'll just do it with one sprite for now. We'll demonstrate. So I'm just going to create some dummy sprite data. We'll stick it towards the end of the Vic bank. Just call it sprites. And I'm just going to fill 64 with 258. So it's just going to create a single sprite that is basically a big square. And we'll do the sprite setup here. So you also, the other place you'll see this effect, this kind of multiplexing effect used a lot, is in demos as well. I need to keep an eye on the chat. For some reason my chat's gone like grey in the background. It's kind of hard to read over here. Sprite stacking. Okay, cool. Oh, Dan Phillips, hi. Oh, I actually used the Armor-like picture for sprite multiplexing because it is, as I'll explain when we get to it, it's one of the best examples of sprite multiplexing in C64 games. That's a general multiplexer. Okay. Apparently my last follower's name was so long it kind of leaks over into my recent subscriber. Snow White and the Seven Dwarfs. Don't know when that was. Okay, so we're just going to set some sprites up. So we'll just turn on one sprite for now. I'm not going to use a Vic label library. These kind of Vic labels you should kind of pick up fairly quickly if you use them a lot. We'll set a colour just so that it stands out, and we'll set a position. So let's set it kind of towards the middle of the screen, but let's put it just kind of peeking it out of the top of the screen. So we get there. We should get a white sprite now. Oh no, we've got no sprite pointer. Hang on. Let's turn that increment off as well. So we need to set a sprite pointer up as well. So if you've followed my other videos, you should know that the sprite pointer is at screen RAM basically, plus 3 FA. That's where the sprite pointers start. So whatever your screen RAM is, we're just going to use 0400 for here. I will put a note on that so when you look at the code later you know exactly what it is. But this will change as we go along. I'm just going to reduce it a little bit. Just let me know if it's too small. Should be just about right. I wonder if you can create suggestion chat by having Discord window open your desktop and make a channel dedicated. Oh yeah, that's not a bad idea, Hayes, actually. Hi, I'm just saying hello to myself. Hi, Cannibal's Delight. Sorry, I'm going to let my cat in because it's crying. Come on then. Come on. Come on. So I'm fully expecting the cat to jump on me at some point. Hopefully he won't knock my cider over. I'm drinking cider tonight as well. I know I've got work in the morning, but I saw the Kofferberg in the shop, I couldn't resist. So we set colour up, turned it on, set its location, set its pointer. That should be enough for now. Cool, there we go. So we've got a sprite in the middle at the top. Now, the cool thing with Vic sprites, well, it's a cool thing and it's a pain in the ass as well, is that if at any point you decide to change the position of that sprite, the X position you can change. So halfway through that I can change its position. If I show you with these raster loops, if I just create 2 IRQs here, so this is going to be the best way to demonstrate this. So I'm just going to copy this code to here. So this is now going to point to our first IRQ, and this one will point to the second one. And if we set the position, where did we say it? 32. So we set it halfway through that. So we do like 3E or so. And we change the X positions in here. So in the first one, we'll keep the X position as A0. And then in the second one, we're going to change the X position. And we'll set it to 90. Now when I run this, you should see that the sprite kind of shifts halfway through. So X position you can change. There are, however, things you can't change, and that is actually most of the stuff. So if I change these, if I create another sprite, a second sprite here, and I change the value in here, I'm actually going to use X because it's a bit easier for me to visualize what the pattern that I'm going to see. So this is what the second sprite looks like. It's bars like that, and the first sprite is solid. So if we change these values halfway through, you'll see what happens. So we set the solid sprite here, and then we'll try and change the pointer halfway through. Oh, actually it has worked on that one. But you can see it's done one line without it first, and this is because the Vic fetches ahead of what it's going to draw. I think it's probably because this is just about over one of the lines. So you can see you can't trust switching the pointer halfway through like so. And even worse, what you can't do is change the Y position. So if I take the Y position here, put this in as well. So now we're changing the pointer, the X position, and the Y position. And say I wanted to make this sprite carry on down the screen a little bit, I could change this to 3E as well. So it now matches this raster. So we should see a longer sprite in theory. But as you can see, it's not changed at all. And that's because Y positions only get read once right at the beginning. So as soon as you start drawing the sprite, its Y position is locked in, and that doesn't change until the sprite is finished. But what you can do is you can change it in this IRQ here. Hang on, let's make that IRQ 3, like so. Hang on, just thinking about this. I'm going to get rid of the X shift. I'm going to get rid of the sprite pointer as well. Actually, no, I'll keep the sprite pointer in. But I'm not going to keep it in that one, I'm going to keep it in the second one. Actually, I could have done it with one IRQ. Okay, I'm going to do it with one, makes more sense. So as soon as the sprite is finished drawing, which is 21 lines, you can move its Y position a little bit. So if we're firing this IRQ just after this one is finished, which is, it's drawing at 32, so if we add 21 to that, that gives us 47. Let's fire this IRQ just before then. Let's do it at 46, and in here we will change the values that we want. So we will change the Y position to 48, so it's ready to draw, so it's just after the raster that's being hit, and then we'll keep the pointer, we'll keep the X position the same. So hopefully now you should see it's drawing 2 sprites now. So if I reduce that down, if I wanted to stack them properly, I need to change that to 47. I need to, actually it'll probably work like that. What flavour? Strawberry and lime today. What I'm also going to do, just so you can see where these are actually happening, I'm just going to increment the border colour at that point as well. So it's going to flash like crazy, but you'll see where it's happening. Actually, let's do it with the background colour instead, and let's do like that. There you go. Why is that not incremented the border colour? Oh. That should be fine. Why is that not? Strawberry and lime. That's apple and lime. That's not the same. Why is that not incremented the background colour? Load the background colour. Yep. Do this. What have I done wrong here? I mean, that should work. I don't know why that doesn't work. Oh. Why am I not seeing a border colour, background colour change? What have I done wrong here? Anyone see what I've done wrong? Yeah, them are strawberries. That's better. IRQ1, IRQ1, IRQ2 draws a new sprite, but it's not drawing the border colour for some reason. Pardon me. Oh god, what have I done wrong here? This is like the simplest code ever, so... Yeah, I had ink D020 and it didn't work, so load, accumulate with 0, store it in background colour, get rid of that one. I feel like I'm missing something really simple here. Let's try it on the border colour. I'm being intrigued as to what the hell's going on there. It works for that, but it doesn't work with the background colour. I'm not sure why. It's a bit bizarre, but you can see this is the line that shows, and we can keep doing that all the way down the screen, and you can draw 8 sprites across, and then you know, on the next row do another 8 sprites, and you can fit a lot of sprites in like that. But the limitation there is that you're not doing any calculation around the position of individual sprites in there. They're all just relative to the start there. What are you doing, cat? The cat's trying to climb up stuff, but she's a bit fat, so she can't. So yeah, you're basically defining the top corner here. So you're defining where your first IRQ starts, and then you draw a row of sprites. Your next IRQ starts 21 lines down from your previous one, and so on and so on and so on. So it's a simple way to kind of create sprites like that, but it's not very flexible. So the next way to do it is to do what's called zoned multiplexing. D021 is screen color. Yeah, I'm trying to set the screen color, but for some reason it's not having it. It's like it's going back to this IRQ immediately. only when I set the border, only when I set the screen color. Just makes no sense. Yeah, it makes no sense at all. I have no idea why it's doing that. Which is a bit worrying that it's doing this all straight away with these things, but I don't see any reason why that would not work here. So no, I don't see any problem with it. Cat 3D printing. Oh my god, where's she gone now? Come up here, you. Come sit in here. Okay. Anyway, this is, for our purposes, this is not kind of what we want to do. So the next, so it's not showing the color around. Change the char set at 0xff. I haven't. Oh, that's a good point. I haven't cleared the screen, and yet. That's a really good point. Why is it doing that? Have I done something weird here that's not set it up properly? Because it does seem to. Yeah, I think you're right. I think it's filled the screen with a blank color. Have I got it in some weird? Maybe I've got it in a weird mode on here. Because it shouldn't. We should still see the C64 stuff. If I turn the background colours off completely. Yeah, why is it doing that? That's weird. Have I done something wrong with the? Hang on, am I being stupid? What have I missed here? God damn it, this is what happens when you drink a bit early before these things. I'm just going to have a look at, let's have a look at the parallax stuff, just to see what I did differently on there. I set the borders up, turned off the kernel, turned on multicolor mode. Yeah, I'm doing everything as I would normally do things. Turning off those interrupts. Yeah, I could not tell you why it's doing that. It's very weird. She's a Bengal cat. She's kind of, she's got a little bit of Bengal in her, I guess, but she's more tabby than anything else. Do you know what? I'm gonna set up the. No, I haven't moved the screen because the sprite pointers are working correctly, so it's not that either. Let me just keep the kernel turned on for now. In which case, oh shit, that's not gonna work, is it? That's not gonna work because I've got that turned on. That's an interesting one. I couldn't tell you what I've done wrong there. Sprite setup, yep. Color, yep. Position. I mean, I've stored a value in the sprite point, and that is it. Okay. I just want to. I just put an RTS set. I just want to make sure that something is. Okay. So something in this lot is breaking it. That's just because I've turned the things off. Is it this? 7FD011. 7F should be correct. Oh no! Oh, God damn it! I know what I've done wrong. I'm storing that value, and I shouldn't be doing what I should be doing. Is anding it with that and storing it. There we go. That's my mistake. Sorry, my bad. But it was still. This should be fine. God damn it. The 7F would have just given me a weird mode. Oh, it's because now this is also the same in here. Yeah. Yeah, so this was the problem. I was storing a weird mode into D011, and I should have been handing a bit. Trying to talk and type at the same time. There we go. That's more like it. And now we get the background color. So if I set that background color to 2, you'll see exactly where the split is on the sprite. There we go. So this is where the raster happens, and the second sprite is down here. We can set the colors of the sprites as well, so that we can be sure that this is working. So let's set. God, this bodes well for doing the general multiplexer anyway. I'm going to try and rush through this so that we can get to that bit fairly soon, because I'm conscious that I haven't written one in 6 or 7 months now, and I'm going to be trying to write one in 2 hours. Cool. Oh, you can change the color of sprites as well, so that by changing that I've actually changed the color of the sprite up here. But I'll show you when we do general multiplexing how we deal with setting colors and sprites on sprites and so. So you can change that by moving that raster down a little bit. It's probably going to be a little bit too quick though this time. The second sprite might not show. I know it has. Yeah. Anyway, so the second type of sprite multiplexing is what I call zonal sprite multiplexing. So if you imagine, let's bring up a char pad. So you imagine this screen. Let's just make a fill character, and you imagine some sprites on it. So I'm going to make a little S to demonstrate sprites. So anywhere I put an S, that means there's a sprite there. So if you imagine without a sprite multiplexer, you're kind of limited to 8 sprites on screen. Now, with zonal multiplexing, what you do is you draw an imaginary. Oops. Oh, it's on global. God damn it. A character. Here we go. You kind of draw an imaginary line across the middle of the screen, or more than the middle of the screen. I mean, you can have multiple zones as well. But the simplest way is just to divide the screen into 2 halves. Now you can have 16 sprites on screen, but you can only have 8 in each half, like so. So one limitation here obviously is that these sprites can't go into here and these sprites can't go into here. So this works best when you've got sprites which move across platforms horizontally. You can kind of cheat a little bit. So what you can do is you can define one or more of the sprites which can cross the boundaries. So if I say I want to play a sprite, I get rid of the one sprite from each area, and now I have a player sprite. Now this sprite can go 8 on either zone. It's not included in the multiplexing. Wherever I put it, it will show. So these ones move left and right, this one can go anywhere, and you can extend that. So you could say, okay, I'm going to have two extra sprites which can cross the zones, like so. So now I've got 5 sprites which move horizontally between these zones, a player which can move between these zones, and 2 other sprites which move between the zones. So I can have an up and down animation that crosses the zones quite easily. Thank you for the host, Coconut. And again, I'm not hearing any of my alerts. What is going on? This is really bad. Oh, it wasn't a host. Oh, it was a host and it was a resub as well. Thank you for the sub, Coconut. I don't know why I'm not hearing my alerts. I had this trouble last time. Thank you for the follow, Backwards Spy as well. I saw that come up on my little panel, so at least I saw that one. So this is called zonal multiplexing, and this is an easy way to do platform games where you can kind of design around the limitations. I believe Creatures actually uses something like this. That alert did show though. That's weird. I'm not convinced by Muxy. Which alert system do you use, Hayes? Because this Muxy alerts is not very good in my opinion. Or I'm just using it wrong. Yeah, the follow alert did work. yeah, so to go back to creatures again, I mean, I can't guarantee this is what they actually use in Creatures 1. I've not actually looked at the code in any detail, but I'm pretty sure, just from the way it looks, that it's done with a zonal multiplexer. The game, come on, the game tends not to, well, it only goes horizontally for a start, and there's very few things that actually cross these boundaries. They do have a couple. Oh, thank you for thank you for the cheer, for the bit, Sandy Magic Knight. Use Streamlabs alert box. Okay, I might have to look into that, because this Muxy one is terrible. It doesn't seem to do the job for me at all. It seems to update my latest and recent, but it doesn't do anything more than that. So yeah, if you look at creatures here, you'll see that sprites tend to stay within these zones. And even here, this sprite's moving up and down, but it never crosses this line here. So this looks like it's a zone, and there's a sprite, 3 sprites here, 4 sprites total plus the player. The player is obviously one sprite which can cross the zones, and then there's, you know, everything else fits within them. Again, this sprite is in the top zone, and you can see it doesn't cross this boundary. And even the sprites that do cross the boundary are probably part of a group, a small group, which is allowed to cross both. Thanks for the follow, Dan Phillips. Appreciated. And also, there's another split down here. So there's a split here which does these scoreboard and stuff in the bottom panel here. So this can be used to great effect, and Creatures is testament to that. You can do a lot with them still. It just means you have to design your levels to take that into account. To a certain extent, zonal multiplexing is used in most games anyway, for things like scoreboards and stuff, but usually combined with the general multiplexer, or it may be the only multiplexing used in the game. Certainly, there's a few games I've worked on recently where I've forgone using an actual multiplexer and just stuck to using just a split to do the scoreboards and stuff. So here you see this sprite here. It's a double width. Well, it's 2 double width sprites by the looks of things, and the kind of bullet he throws down is a sprite that's allowed to cross the zones. So again, it's an effective way of doing things. I'm going to show you very quickly how to do that. I think we've kind of touched on this before. So what I'm going to do, I'm going to enable all the sprites this time. I don't care about colours. In fact, I'll increment the colours as we go along, and I'll set the positions up in... actually, I can set the positions up here as well. Okay, so what we're going to do, we'll just create a loop here. We're going to set the Y position and the colours of things. I'm going to set 2 registers here, simply because it's a little bit annoying setting the Y positions of sprites. So we're going to set a couple of 8 sprites at this position. Actually, sorry, no, we want the X positions, not the Ys. We're going to change the Ys in the raster. So we'll start at this position. Actually, you know what? I'm just going to cheat. I'm just going to do it with a kick assembler loop. It's just easier for now. I know she's going crazy. What are you doing? Here. She's a bit of a handful at times. Okay, so we're going to set some X positions based on... that'll do. And we're going to set a colour, which I will... yeah, let's just do I+1. I'll set the border to black so it stands out. There we go. I don't need all this crap anymore. I do need this. What assembler do I use? I use Kick Assembler to do this. Other assemblers are available, obviously, but I do all my stuff in Kick Assembler. I keep doing that. I got caps lock on. Okay, so we're setting up 8 sprites going across the screen. I'm going to set the border and background to black, just so we can see them. And then here, all I'm going to do is just change. I'm going to get rid of these changes. It's going to be really obvious where those are. So what we'll do is I'm just going to copy another loop into here for each one, and we're just going to set the Y position there. In fact, that should be that. So we'll start by setting the Y position somewhere at the top of the screen. We'll copy that to all 8 sprites, so we don't need any of this. And then in the second loop, we will just move them down the screen. We'll stick them down at about 80 or something, and we'll just set this split up to happen just some time before it. That's usually about right. And there you've got 16 sprites on screen. So the zone is round about here somewhere, and we can repeat that down the screen if we want. It's kind of similar to the stack sprites, but what you would do is you can set these positions individually, and they're not as tightly together. So say we wanted this sprite to move between the two, what you would do instead is you would just set the Y positions of these sprites here, ignore the first one, and you'll see when I run this, only one sprite will appear. Oh, where's the other one? Not there. Oh, because I haven't set this position yet. So if let's just create a value in here somewhere. Let's call it sprite 1 pos. Set it to like 40 or something like that, and then in here, in this first one, doesn't really matter where you do it. We'd probably do it in a different loop somewhere. There we go, and I'll just increment that value, so it'll just keep looping around the screen. Yeah, 64 TAS seems to be another kind of option that people tend to go for. Why is that not working? So D01, yeah, that should be fine. I still need to set the X position on that one. It's this one. There we go. So you can see we've got one sprite which can move between the zones, and that's because we're not including that in the multiplex. The multiplex is just changing the positions of these 7 sprites, and this one can move between. So this is kind of the next easiest sprite multiplexer to do, but that's not the one we're going to really kind of focus on tonight. We're going to try and do a general multiplexer. Now, I'm going to make no guarantees that this is going to be the most efficient multiplexer in the world. I am going to be doing it from memory. I'm going to try and remember everything I need to do in it. I may copy paste the sprite sort routine. I'll explain. In fact, I'll tell you what I'm going to post now. There's a really good tutorial on Cadaver's site. What's it called? Covert Bit Ops, is it? Covert Bit Ops. Yeah, Covert Bit Ops. There we go. Sprite multiplexing. I'll post a link to this page. Or is that not showing up? It's just showing up that. Let's see if I can copy the link. Copy link address. There we go. So that's got a really good explanation of these techniques. It also has some discussion about the different sort routines as well. I tend to use there's a sort routine in here that's adapted from Swiv, the game, the top-down Jeep and helicopter game. That's the sort routine I tend to use. I've modified it slightly for my purposes, but I kind of based it on that, so we'll probably go with something like that. So a general multiplexer is a lot more than this. So what a general multiplexer will do is it will take a list of sprite locations and display them on the sprite locations, positions, pointers, and things like that, and display them somewhere on the screen. For what I'm going to do first, I'm just going to create a dummy block of data. We'll move it into 0 page eventually, but for now we're just going to create here. So we'll create a sprite X, a sprite Y, a sprite color, a sprite pointer. You could add more information into this. I am going to add sprite X MSB as well. Again, as I say, this is not going to be the most efficient thing in the world. And a max sprites label. So I'm going to do this with a label. And we'll do a simple amount first. We'll do 16 to begin with. As you add sprites to these general multiplexers, the routines needed to sort them and display them get heavier and heavier to run, and that's where the limitations tend to come in. My cat is going mental. I can hear it over the other side of the room. What are you doing? Mia, can you say hello to everyone? No. Oh, she's disappeared somewhere. Probably burrowed under some stuff. Oh, you're on a Chromebook, Andy. Oh, I'm sorry. I'm very, very sorry. That sounds horrible. Chasing ghosts, yeah. So I'm just gonna fill some values in here. What is she doing? I'm gonna fill some random values into here for the X position, and we'll go through kind of how to work with this. Cat seems to be a common. What she do? I can hear her scratching her ears. What are you doing? No, that's fine. Come on. Come here. She's trying to get inside a carrier bag, as they do. We'll just pick a number up to 200 or something. 210, that'll do. 24. Actually, let's go all the way up to 255. I'll set the MSB to 0 for now. We'll deal with that when we get round to that. And I'm going to pre-order this list as well. So I'm going to show you what we actually need to do once the list is ordered. So I'm going to fill this with 32 plus I times 18. That should be enough. This can be times 15 plus 1. Yeah, 15 plus 1. Yeah. Okay. So if we were to just try and draw these on the screen, obviously we're only going to see 8 at one time, so we need to figure out how to split that. Redeem cat hugs. when she comes out of wherever she's burrowed into now, I'll bring her over and give her a hug. She tends to jump on the back of my chair as well, so at some point you'll probably see me jump as she dives on the back of my chair. Why she does it, I don't know, because she tends to climb over me and then go under the desk, which is a much less efficient way than just going under the desk. Okay, so let's get rid of all this crappy setup here that we don't need. We'll keep all the sprites turned on. We'll keep jumping to that loop. We will relocate this to the 0 page in a minute, but for now I just want to show you how this works. So in our IRQ loop, which we can start at 0, by the way. So what we're going to do is we're going to start our IRQ at 0, which is here. We're going to keep a record of which sprite we're on, which we'll store in sprite index, which is always going to start at 0. This list is we're going to assume this list is already ordered, which it won't be when we do the full multiplexer, but we're going to do this. So the way this works is you draw sprites until you get to a point where the next sprite is, you keep drawing sprites when they're close together. So if the next sprite is within 3 or 4 or so of the sprite after it, I think you want to write my cat's code, yeah. If you want to, hi Warlock, welcome to the stream. So you draw your first sprite. Let's show you on here again. I draw a sprite here. Let's just delete all of that. So I draw a sprite at the top of the screen here. This is my first sprite. So if my next sprite is close by, like that, let's assume this is, well, let's put it on the same line. Let's assume this, if it's on the same line, it means it's within 3 or 4 pixels of Y height. I also draw that sprite, and I keep drawing until the next sprite is more than that. When that sprite is more than that, I stop that raster. I finish doing that raster, and I set the next raster up to be just before the next sprite. And then I do the same again. I keep drawing sprites until the next one is further down. And I draw a line. I set the new raster up to be this line. And then I draw again. And so on and so on until you can make that bigger. I can make that bigger, can't I? Yeah, there we go. Until I get to the point where I've used all my sprites up, until I get to the end of my sprite list. One trick you can do for disabling sprites is you just set the Y position to like FF or 00 and you have it ignore those. I tend to use FF because it means it's at the end of the list. So as soon as I get to a sprite with a Y position of FF, it means it's off the screen, and I know all the other sprites after that are also going to be off the screen, so I stop rendering at that point. And multiplexing cat could be in several places at the same time. It sounds like a recipe for absolute mayhem. Yeah, that would be absolute chaos. Okay, so with this in mind, let's do that with this this list. So we're going to get rid of the second IRQ because we're only going to need one to do this. I'm going to indent this bit here, and everything else I'm going to redo. So this is the last thing we're going to do. This is going to set up the next line, and here we're going to work through the sprites. So this is going to be very inefficient code, I tell you that now, but it's going to be functional. I'm going to leave most of the optimization down to an exercise for you guys to do if you want to take this further. We don't have an awful lot of time. We've got about 2 hours to kind of get this working, so let's give it a shot. Okay, so the first thing we need to do is we need to get the current sprite index. So we need to know which sprite we're looking at next, and that's going to be this value here. Every time we draw a sprite, we increment this. If this gets to the same value as max sprites, we're finished. If we're finished, we change this back to 0 and we start again. So first thing we're going to do is we're going to grab all the information for this sprite and draw it on the screen. So, oh, the other thing we need to keep track of as well is our Vic sprite index. So the Vic sprite index is the current sprite that we're going to draw to. This will go from 0 to 7, and then it will reset back to 0 again. We need to keep a record of this because as we draw sprites, we may draw 4 sprites. So this would be 0, 1, 2, 3. The Vic index would now be on 4, meaning the next sprite that's drawn is going to be 4. This would be 4, 5, 6, 7, back to 0. It's just a way of keeping track of which sprite we've drawn. So I'm going to load that into the accumulator. I'll show you why I'm going to do that now. I am then going to actually, let's think about this. See, this is a problem. I'm trying to do this off the top of my head. Let's start by setting the colors and the positions. We can do everything that's, so sprite Y and sprite X, these ones here, well actually this one and this one here need our index to be doubled because X, Y are in pairs, so it's not as easy as just indexing with the Vic sprite index. So I'm going to store that in Y. And so we're going to start by doing the colors. So we'll load our sprite color from our index, our current index. and we'll store that at our sprite color for our current Vic index. Cats already tend to do that, and yes, it's mayhem. Yeah, I think cats do have an innate ability to be able to just be in all places at the same time. Except where you want them to be. If you want them to be somewhere, they won't be there. Innate, not inane. Innate ability. So we're going to load the sprite pointer, and we're going to store that at oh, I deleted it. Okay, so the sprite pointers again are at 0400 or wherever your screen RAM is, plus 248. So we've set the color, we've set the sprite pointer. Now we need to set the X and the Y. We'll do the MSB last. I'll show you how I do MSBs, but we'll do that one last. So we're going to set the X and the Y. So what we need to do now is if we just transfer the Y to the accumulator and double it, used by shifting it to the left, and then transfer it back. Now we have a value that's 0, 2, 4, 6, 8, so on. So now what we can do is we can grab sprite X and store that at sprite, sorry, not sprite, store it at D0000, comma Y, and sprite Y would be D001, comma Y. So now we've set the X and the Y values. We're going to set the Y last because this is what we're... Actually, no, it doesn't matter here. We do it on the next sprite. So we will increment our sprite index. We'll load the Y back again. Increment that. This is probably an easier way of doing this actually. Let me, yeah, I'll tell you what we'll do instead. We'll transfer Y to the accumulator. Oh no, it's double, isn't it? Okay, yeah, we'll do that. If the sprite index has reached 8, then we need to set it back to 0. As I said, this is going to be very inefficient. And we store that in Vic sprite index. And when we increase that, in fact, we'll do the X last. So we do the Y first. There we go. And then we'll increase the X here. Whoops. If this is the same as our max sprites, then we're finished basically. So we'll create a label, call it finish. I'll put this here. And we'll call this exit raster here. So the exit raster is just going to set up the last bit of the raster and exit it. Finish is what is actually just going to reset everything back to 0 again. So we set our line back to 0. We set our Vic sprite index back to 0. And we set our sprite index back to 0 as well. Otherwise, we need to make a decision here. We need to grab the next sprite Y in the list. And we need to subtract a small amount from it. We want the raster, we want the next raster to be a few lines before the sprite is drawn, just so it can deal with any timing issues and not miss out sprites because they're there. So we'll subtract, let's subtract 3, that's probably enough. So now we have the Y position of the next sprite minus 3. So the first thing we're going to do is we're going to compare that to the line that we're on. If that value is less than the line that we're on, is that right? Yes. If that value is less than the line that we're on, then we just need to jump back to here basically, and we just need to do the next round. We've already got the X, I think. yeah, we've already got X stored, so we'll just jump to here. We'll call this loop in here. Otherwise, we will store that value in D0, 1, 2 and jump to exit raster. Hi Smash Jenkins, welcome to the stream, and Sin Lau as well, didn't see you come in. Welcome to the stream, guys. So to talk through what this is doing very quickly, so we come into this raster interrupt at line 0, and at line 0 our Vic sprite index, so the current Vic sprite that we're going to draw to is at 0, and our sprite index, our kind of index into our list of multiplex sprites is also at 0. So we load those values in, and then we grab the sprite color of the first sprite and we store that in the first Vic sprite. Same with the pointer. Then we double the Vic sprite index so that we can store the X and the Y, and then we do some comparisons. So we increment the Vic sprite index, making sure that that wraps back round to 0 again. You could probably do this with just an AND somewhere instead. In fact, let's do that. I think I can save a few bytes if I do, save a few cycles if I just do this. Actually, that should be enough, because if I do this, yeah, that should be enough. That's probably better than doing all of this. As I say, you might want to mess around with this a little bit. So we just keep incrementing this sprite index, and we just AND it with 7 here to make sure it stays between 0 and 7 when we want to use it. Becoming a cowboy. I've always written colour like that. I know I'm hi Citizen, welcome to the stream. I know that I'm British, but I've just been coding for so long that I've always written it like that. I'm the same with, unfortunately, because of that, I also write things like honour, favour. I tend to write those without the U as well, even though they're not the sort of thing that I ever write in code, but I've just kind of got the Americanism of the OR ending instead of OUR. Yep, so we set the X and the Y, and then we increment the Vic sprite index, so we cycle through the sprites from 0 to 7, just keep repeating. We increment our sprite index, our multiplex sprite index. If that's reached the maximum sprites, we stop and we jump to finish. Otherwise, we take the sprite Y for the next sprite. We take 3 off it and compare it with the current raster line that we're on. If it's less than the current raster line that we're on, then we don't set the next raster up. We just jump straight back here and start drawing the next sprite. However, if it is more, then we will store that value in the raster, the raster pointer for that line, and we'll exit the raster. So then the next time this runs, it will run at the next line and draw the next set of sprites and so on. Finally, when we do finish, like when we hit this, we just reset all this. We reset the Vic sprite index, we reset the sprite index, and we store that value in D0, 1, 2. Okay, I'm gonna go for I'm not even gonna run it yet. I'm gonna go for a quick break, and when I come back, we will run it. So we'll see how it works. We'll see if this has worked. You know, Shalom can't resist this chance to save a byte. Yeah, I'm just saving bytes. I want my text files to be smaller. All right, I'll be back in 2 minutes, guys. Be right back. Hi Prince Phase, welcome to the stream. Judgment. Do I put an E in judgment? I think I do actually. I still spell that right. I think it's just the O-U-R. Oh no, also with center as well, so I spell center like this. I know it's supposed to be that, but I spell it like that. Sometimes I think that's one that chops and changes a lot, but I do generally spell it ER instead. So Okay, so let's give this a try, see if this actually works. So it's failed straight away because it's trying to jump back to IRQ2, which no longer exists. So let's turn that back to that. So we've only got 4 sprites on the screen, so something has gone wrong here. So it's drawn the first 4 and then it's kind of failed elsewhere. So let's have a quick look in the debugger. See what the hell's going on. Oh, what have I done? Have I paused it or something? Oh, it's crashed on me. Oh. I'm having a lot of issues with the latest version of the debugger actually, I don't know why. Oh, you can see it on there, so you can see it is actually placing them down the screen, but they're just not showing for some reason. I don't know why. You can see the placements, but for some reason I'm not seeing them on here. I'm just going to double check that those values are properly consecutive in memory. It might be that I've got a sorting issue here. 16 times... Oh, yes, of course. It's because I've set these values wrong, that's why. The Y values were going over, so that's why it was failing. So a lot of flickering. So this is the problem with Sprite multiplexers. When they go wrong, this is what happens. You get lots of flickering. We can just change these values a little bit, so we space them out a little bit. Still getting flickering. Why are we getting flickering? This is my comparison the wrong way around, maybe. So I take the current sprite, I compare it to the line that we're on. Ah, no. Compare it to the line that we're on. Just try changing that a sec, hang on. Yeah, I've done that comparison wrong. Hang on. So this is what's wrong. I need to set the next raster up. So what I need to do, I need to take the sprite that's coming next, and I need to check if this sprite close. So actually, what I'm going to do is I'm going to load the value of D012. I'm going to add 3 to it, and then I'm going to compare it to that. And if this value is more than this value, then we're just going to jump back to the loop. That should be better, I think. So it's been a while since I did this, it's tricky to do it straight away. No, something's going wrong. What am I doing wrong here? Take the current line that we're on. Oh, because now I need to actually... Yeah, see, there's tons of optimization to do around this. I should have maybe just taken my Parasol Stars multiplexer and dissected it. That would have probably been easier, because I'm making a right mess of this. Oh, I think I had it right the first time. I think I'm just doing something a bit odd. We can step through it anyway. We can see what's going on. We put some breakpoints in and we can step through it and see what's actually happening. Let's just reverse this to where I had it before. Okay, that's what I had before. Let's keep that at 8 apart. Let's see, what's 12 times 16 plus 32? That should be fine, actually. Okay, so if we just drew the first few sprites, what would happen? Let me cancel out this bit here. Let's just make sure that that draws a few sprites. So it draws one, and then the next one's far away. So the next one would be, well, let's just imagine that they are far apart now. So let's just deal with that, and then we'll start moving them, some of them closer together, and we'll see what happens. So we would get the next sprite in the list, subtract 3, and store that D012. So this is doing a separate raster for every sprite on the screen. It's still not working. Why is that not working? I'm incrementing a Vic sprite index. Oh, I'm not storing. God damn it, I'm just being stupid, that's why. I'm not storing that X value. There we go. So all I'm doing here is I'm drawing one sprite, setting the raster up for the next one, drawing it, setting the raster up for the next one, drawing it, setting the raster up for the next one. Now that's fine until we start moving them close together. So instead of this fill, what I'm going to do is I'm just going to create a I'm going to create a loop here. Let's call it Y. It's going to start at 32, and then I'm just going to add it there, and then on the next line I'm going to do eval YY. I think you can do this plus equals, and then I'm going to do random times 8 plus 2. So now they're going to be random distances apart, times 12 plus 2. And you'll see it'll kind of half work in places, and it'll be flickery in other places as well. And this has actually just worked. That won't always be the case, that will fail sometimes. Of course it's bloody working every time. So the problem is if these sprites are very close together, it's not going to work properly. And you'll get there we go. So you're getting flickering now, and that's because it's drawing some, and then when it tries to set the raster up for the next one, it's not. It can't do it in time because it's being drawn too soon. So we need to get rid of that flickering, which hopefully happens every time if I do this. Yeah, there we go. Right. And that's because now we're just setting one raster up per sprite. So what we need to do is we need to actually do this comparison here and make sure that if a sprite is close enough, we just immediately draw it. It's better, but we've still got flickering. We can change the padding on this as well, so it draws a few more of them before it starts flickering. Okay. Try a lower value. So what's going on here? We're drawing this one, and then it's probably gonna draw a raster for this one. Yeah, there's quite a few that it's drawing. I think it's just because there's a lot very close together. To give you an idea, when I did my last sprite multiplex, I took quite a long time to make it. So doing this all in one go is kind of it's tricky, to say the least. Just need more alcohol. So here I would expect it to draw one, and then the next one would be a new raster. Maybe draw 1, 2, 3, 4, then a new raster, 1, 2, new raster. So this should be possible to draw. It's just something set up incorrectly in here. So we'll leave that as it is, because I think that's a good kind of test for it. So we're drawing it, we're incrementing the sprite index, incrementing our Vic sprite index, take our sprite Y, subtract 4 from it. That should be enough. If that value is less than our current line, then yeah, this should be fine. It's just getting the padding right. But it's not for some reason. It seems to be struggling. They're definitely being drawn in the right order, aren't they? This is just increasing as it goes along, so this should be fine. Change that to 12 just in case it is looping round. It shouldn't be though. Yeah, I mean this should work even with quite a high number because it's using random. So okay, I'm going to leave that around about 20, and then we'll work at what's she doing now. What have you got? Oh, perfect. It's not going to bloody work every time now as well. I need it to flicker a little bit. Oh yeah, let's do a increment on the border. Yeah, so if when we enter here, we'll increment, and when we exit, we will decrement it here. So let's have a look what's going on. There's probably something weird going on in here. Okay, far too many raster lines being done here. So the first one's happening here. I think what's happening is that the next raster line that's being triggered is too late. It's already gone past it. So we're getting some on one frame. In fact, if I pause it, you see we've got them on one frame. Those on the next frame. So this is what's happening frame by frame. It's skipping some that are too close together, and that is probably due to this here. If we just increase the padding to something ridiculous like 8 or something. There we go. That's much better. And this is where Sprite multiplexer optimization is very useful. So the longer it takes you to draw the sprites, the bigger that padding needs to be between. So let's call this padding actually, and let's stick a value in here. So the longer it takes you to do this block here, then the higher that padding needs to be as you go along. Oh, thank you for the follow, Tasty Graph. Sorry I missed that. My alerts are playing up for me today. I don't know what is going on. I don't want to turn them up super loud in case it deafens you lot, but I'm definitely not hearing anything. In fact, I can't even hear any sound. In fact, you know what I'm going to do? I'm going to switch to my monitor sound. I did have some problems with my where do I do that now? It's here, isn't it? Yeah. I did have some problems with my speakers the other day, so maybe it's something to do with those. I don't see sound on here for. Let's do it on that. Instead of coming out here, maybe. Audio volume. See if I can actually hear anything. No, I can't even hear the SID music. Very weird. I don't know what's going on there. I'll just have to keep my eye on the feed as it comes through. It's really strange. Actually, let me try resetting the block here. Where is it? There it is. Okay. Oop. Still can't hear the SID music though. Yeah. Starting to think I need a different sound solution. I'm using a SteelSeries DAC and I don't think it's that great, to be honest. Yeah, so changing this padding, if we make this padding really big, it will be less rasters, but there'll be more chance that we draw more than 8 sprites in an area. which is kind of happening in here, I think. If we reduce the padding, then there's a chance that the work we do in one sequence will overlap into the next one. So getting this value right is kind of critical, and it depends on how fast you make your routine. So a really good routine, you're probably looking at 2 or 3. Thank you for the follow, Shadowzar. Welcome to the stream. But for this, it seems like 8 is our amount. I mean, that's quite big. That's not a good padding amount at all. In fact, that's not working now either. Typical. It is producing a lot, isn't it? Yeah. So we've got one at the top, which draws this one, and then this is the next sprite, but for some reason it's got 2 here. Let's just put the padding on 1, see what happens. So this is just drawing. How many is he doing? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Do you see this? Even this one kind of looks weird as well. Do you know what? It's time for another cider, one I had prepared earlier. We've not even gotten into the sorting yet. So the only thing that sorting is going to do is it's going to create this ordered list. Oh, that's good. Let's put the padding back to 8 and work out why there's too many rasters. Yeah, I spotted that one, Warlock, thank you. Yeah, welcome to the stream, Shadowzar. Yeah, I would expect there to be only 1 here, but it's drawing 1 for each one here. Probably just 1 here as well. It's definitely drawing more than it needs to. I still think that comparison is wrong. Let me have a look. If the next sprite compared to our current raster line, this shouldn't be doing so much. It's kind of, oh God's sake, I've done it again. See, this, you need to make sure that you're setting the right value in here. I was doing all this and rearranging it and then actually setting the value back in there again. So this is better, but now it's missing loads because it's reduced the padding. It should be fine. What is going on? Max sprites, yes. Okay. Our sprite Y positions. Let's make this 12 so we can guarantee it's not going to be overlapping into the next one. And yet we're only seeing 4 bloody sprites. What is going on there? There's sprite Y, X. Oh no, this should be right. It should be storing it. That is correct. Hang on. Is it because sometimes it's skipping a line? Ah, yeah, I was. Okay, so what was happening here was I was working out this value, comparing it to D0, 1 and 2. If it was less than that, I was jumping it back and looping. But the problem is if it's exactly the same as that, I was actually carrying on. This is wrong. I should only be setting it if it's 3 ahead. So I think what I should be doing is what I was doing before. I draw the first 8 sprites. No, you see, I'll show you why that's a problem, right? If you draw the first 8 sprites, and the first 8 sprites look like this, Right, so I've got 12 sprites on screen there now. If you draw the first 8, you're drawing these ones, and now you've got these 3 sprites here, which are actually at the same line here. So you can cause problems with this. You can cause you can cause a situation where you might actually miss off some of the sprites. So no, I've set the sprites to all start from white. I used to draw the 8 sprites first and then set the rasters up for the rest, but you can cause some issues with that, especially when they're close together. If you've got 2 rows of very tight sprites, it will cause issues. So the problem is that I was setting the next raster to be exactly the same line as we were on in some cases, which was causing an issue. So instead what I'm going to do is I'm going to take the current line that we're on and test it the other way instead. Which I'm then gonna, the last thing I'm gonna do is no, see, I think this is wrong. Hang on. Press Sprite Y, comma X, subtract our padding. If it's less, oh, do you know, I'm just going to do, if it's less than our padding times 2, I'm going to do that. And then what I'm going to do is I'm going to add some of that padding back here. So now when I change the padding, yeah, there we go, okay. I think that's better. So I should be able to tighten that padding up a little bit now, I think. Yeah, there we go. So now it's only doing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I mean, it's still doing 13 rasters, but it's because there's only a few that are really close together. I should be able to get these a lot closer together now. If I do, where is it? Do that. They should be able to get a bit closer together now. Yeah. The problem we've got here now is that they're so close together, sprites are overlapping each other, and there's more than 8 in a region. So sprite number 8 is being drawn before sprite 1 has finished. But again, that kind of tight formation you probably won't have very often in games. Okay, so I think we've got the basics of it here. We'll look at increasing the count. In fact, I'm only seeing 4. I'm only seeing, oh yeah, some of them are on top of each other as well, I think. Yeah, let's just spread them out a little bit. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Yeah, that's enough sprites. Cool. So that's the basics of a general multiplexer, but in order to make this work fully, we need to actually be able to move these sprites around. So we can move these horizontally, and the plexing will still work exactly as it does now. But if we start moving them vertically, then the Y orders become wrong. So if I change this here, if I just comment this out, and I just put random values in here instead. So if I do 32, so you can actually see it, and then do random times 200, that should be fine. Let's do 180 because there's a gap at the bottom of the screen as well. We're only, actually, I'm impressed that even worked. I don't know, that should be flickering like crazy, I would have thought. Why is that not flickering? I would have thought that would have flickered, because now the sprites are no longer in the Y order, they're all in a... it's just missing some out, I think. I don't know why that's... I would have thought that would have flickered, but apparently not. There is a VOD, but I don't know how useful it's going to be. This is kind of... this is kind of difficult to do live on stream. I generally, when I've done these, I've only done general multiplexing maybe 2 or 3 times, and I've always spent quite a long time doing it and getting it right and optimizing it. But it's handy to explain how to do these things, even if I'm not showing you the most optimum way to do it. You can always work that out at a later date. So the next job we need to do is we need to sort these sprites. I'm going to actually set them up in a pattern so that they start moving, and you'll see the problem with what we've got. So I'm going to do a very simple sinus loop. I'll call it circle. I'll call it circle X and circle Y. And I'm going to fill this with 256 values, and that is going to be sine of the I value times 256 divided by 256, sorry, times math dot, it's not math, it's just pi, times 2, and same with cosine. And now I need to give them a radius. So let's make the radius 100, and I need to give them a center. So if the radius is 100, the center has to be 55 at max. So let's make it 50. Sorry, 150. It's 150 across 100. Yeah. Okay, and same on the bottom. And we'll make circle index. And what we'll do is in this area here where we do this before we finish the final one, we'll just do a little kind of update. So what we're going to do is we're going to take our circle index here, we're going to increment it. So I was just going to put in here demo animation, so we know what's actually going on here. Then I'm going to transfer that to the X register, and I'm going to load circle X, comma X. I'm going to do this in a loop as well, which is going to start at 0. So we're going to load the circle, we're going to store that at sprite X, comma Y. Right, there we go, and then we increment Y, compare Y to max sprites, which might equal back to there. But we also are going to increment this value, so we're going to transfer that back to the accumulator. Are we ever going to, we can keep it, we can do the clear up here. Oh no, we do need to clear because it might overlap, it might overflow, which is fine. Actually, if we do, there we go, and then transfer it back to the X register again. Why is that not going round? You can see we've created the circle, but for some reason it's not going round. We need to reduce the Y height as well. It's a bit too high, so I'm just going to reduce the height a little bit there. So this, yes, let's do that 140 or so. Why is it not going round? It should be going round. Increment the circle index. Transfer the key. Oh, for God's sake. This is a problem when I rush code. I just make so many mistakes. There we go. So now we've got sprites going around in a circle, but as you can see, the sorting screws it up. So there's only one position where, in fact, there isn't one position where these work because there is an overlap in the middle. But you can see we have got 16 sprites. They are kind of drawing. and you can see the rasters are updating, but as the rasters are based on the Y positions, they start filling up down to the bottom and not actually spreading out like they should do. So in order to do that, we need to sort on the Y. And the easiest way to do this, so we could just sort this entire list, but obviously you'd have to move 1, 2, 3, 4, 5 values at a time every time you want to swap two indexes. So the easiest way to do this is by keeping a sprite order as well. So we start with the sprite order, which is just in perfect order, and what we do is we rearrange this list instead. So in order to make use of this, what we have to do is when we get this X value here, so we're getting the next sprite in the list, but that sprite needs to be sprite order, comma X, and then transfer that to the address. So this is the value that we're actually going to work with when it comes to grabbing the sprites. It also means when we increment it here, we need to get it back as well. So we need to make sure we're only ever incrementing the sprite index and then using that to get a sprite from the list as well. So when we run this, it should look pretty much the same as it did before. And we need to do the sorting as well. Yeah, I may show that sorting video. I'm not going to go through the sorting routine in much detail. I'm just going to copy paste the one that I've used for Parasol Stars, because it's the Swift sort from that covert bitops page. But I will show you the Hungarian sort. So if you are not familiar with sort algorithms, there's a really interesting set of YouTube videos which I'm going to show you now, which demonstrate sorting algorithms through the medium of Hungarian folk dance. I'm not going to play it all, but I'll play a little bit so you can get an idea of just how ridiculous it is. But it's actually a really good way to visualize these sort algorithms. I'll just play a little bit of this now. It's absolutely genius. So what they're doing, they're comparing their numbers. If the number's higher, he just goes back into line and passes the hat along to the next person. And this continues. Again, 5 is higher than, was it 3 he's got on? So he goes back into line, passes the hat along, and now this guy's number is lower. So at this point, they swap places. And he passes the hat this way, and the comparison happens again. It's just ridiculous, I love it. And now they get to the point where they have to swap again. And then he passes the hat along, and now they both are next to each other in the line. Nobody needs to swap. So the last person to compare goes back, and he's complete now. So he turns his back, and he's a sorted number now, and then the process repeats again. And it repeats with the group on the right, on the left, sorry. And so on and so on and so on. I'm not gonna go through all of this, but there's ones for shell sort, there's ones for all sorts of sorting algorithms, and it's a really good way to explain it, really. So if you're stuck for kind of how to learn these, and you want a bit of a laugh at the same time, then I definitely recommend these. Good one, yeah. Yeah, and they're really good, and they even do they do a heap sort as well, which I thought was brilliant. Heap sort Hungarian. Yeah. Let's skip it on a little bit. So even demonstrates some quite complex sort algorithms. I wish they'd tune their violins though, they don't sound very well tuned. But yeah, so those videos are on YouTube. Just search for Hungarian folk sort and you'll find loads of them. So there's probably about 8 or 9 of them. Maybe more, they're just the ones that I found. So bubble sort vertically with bunk beds, yeah. So instead of using big O notation, you need to use Hungarian folk dance notation instead to describe the complexity. I would not recommend using Hungarian folk dancers to sort for a Sprite multiplexer though, or you'll never get the sorting done. So I am going to copy my sort routine. I've kind of done this a long time ago, so I'm probably going to have to just make sure that this is all correct. Yeah, okay. I'm going to have to refactor it a little bit as we go. So I'm going to create a routine down here. I'm going to call it sort. I'm going to drop this in. And let's have a look. So this is a Swift sort. And so I think all I need to do is change my sprite order. Sprite order is what we're trying to sort, which is this one, comma X. Where's that +2? Hang on, I've got this. I've also got it on another page. So, as I say, this isn't going to make an awful lot of sense to you guys. It doesn't make an awful lot of sense to me, to be honest. But okay, it shouldn't be +2. This is because I had 2 sprites that I didn't keep outside the multiplexer. So I'm going to get rid of all the +2s. The -1 stays. This routine is detailed on the Covot BitOps page already. So at least Hungarians are numbered, unlike Shout. Yeah, I'm not numbering the sprites. No way. So if you want to see this routine in, I think it's in task format actually, or Acme format or something. It's in one of those formats I don't quite understand. Actually, it kind of looks like Kik. It doesn't look that complicated at all. But it is on the Covert BitOps page. I'll post the link to it again. And this is kind of an adaptation of the Ocean sort routine, apparently. So if you're playing an Ocean game, particularly the later ones, they probably use some kind of version of this sort routine. So I need 2 temporary variables, which is fine. I'll just go and create them at the top. So so 02 virtual temp1. I have tried doing my own sort routines and none of them have ever ended up as fast as these ones, so I've just kind of stuck to this. I think sometimes you just have to accept that, you know, people have spent a long time optimizing these things. You may as well just use the best solution. Max sprites, again not -2, and put an RTS on the end here. Sprite order. So the data YPOS is just called Sprite Y, I think, isn't it? Yeah, Sprite Y. So even with a general multiplexer, you may want to keep 1 sprite or 2 sprites, depending on your needs, for the main player. So if there is any kind of flickering as the multiplexer runs into its limitations, then your player isn't affected by that. So you kind of want your player to stay static and everything else to potentially fall foul to the multiplexer. Thank you for the follow, Probably Tasty. Welcome to the stream. I think that's it. I think that's all I need to do. I'm not sure what kind of sort this is, so I've not actually looked at it in any detail. It seems to be going through... It might just be a straightforward shell sort, to be honest. I'm not sure. I've not looked at it in detail, so I'm not going to bother either. So when we've done this circle setup, we will just jump to the sort routine, and that should sort the sprites in Y order now. So hopefully, with a bit of luck, this should run without the kind of weird behaviour. Note something's failed. Restore Y, comma X. How has that even been working before then? Oh, this is because... right, okay, this is where we're going to actually start using the 0 page. So this routine uses this command, which you can't do unless this is a 0 page address. So I'm going to start moving stuff into 0 page. So what I'm going to do, I'm going to keep a copy of this. I'm going to move a copy into 0 page. Now obviously these values are not going to get filled in, so I'm just going to fill them with zeros, because it's a virtual space, so they're not going to get filled in. So we need to copy the data into there. So what I'm going to do is I'm just going to put underscores on these so we know what they are, but they don't share the same name. So we can change the data here. Data end. There we go. And then I'm going to make a little routine up here which just copies that data in. So and this is all going to go into here. Yeah, so one of the other advantages of using 0 pages is a few instructions that only work in 0 page. Thank you for the follow, C Pressland. Welcome to the stream. Thing on a spring. I wish I could hear the music. I can't hear any of it. I can't hear any of the alerts or any of the music or anything. I don't know what is going on. Yeah, I don't know what's going on there. Actually, let me check my advanced audio programs. Maybe on... No, all my monitors are on. I should be able to hear everything. I don't know. I don't know. I give up. I give up with my audio. Yeah, I'm left. Maybe I should just stick the Hungarian folk music on and just listen to that. It can hurt if you put your thing on a spring. Yeah. Okay, so store there, increase X, compare X to data end minus data. Okay, so now our routine is going to be a little bit quicker because anytime it makes a reference to these, they're actually in the 0 page. It also means our sort routine will work because this now is referencing 0 page. So we should be able to compile this properly now. We still must be able to determine the size argument on the first pass. That is because my max sprites label is outside. So I'm just going to move that to the top of the file up here. I'm going to indent some stuff because it's starting to look a bit messy. To indent that, and let's indent this stuff here as well. Itchy nose. It's still not right, so let's have a look at what sprite order is doing. So sprite order should be at so 2, 3, so this starts at 4, so this would be 14, 24, 34, 44, 54. So let's have a look at 54. It's like it's not sorting them at all actually. Let's go and have a look in the debugger. The debugger is such a godsend. I wish I'd had this back when I was doing this the first time. It does seem to be sorting them, but you can see the rasters don't seem to be working. The rasters seem to be going up to the top and then falling down again. But this order is actually working. You can see if I don't know how well you can see that, but this is the order list here, from here to here, and you can see it is actually rearranging this list order, but it does seem to be having an effect on here, so maybe our main loop is wrong. So let's just check that. Our main loop should takes the current sprite index, grabs the sprite order that relates to that, and transfers that to the X register. And then this is all to do with that. Then we get the sprite index back, compare with sprites. Oh, it's because... oh no, that should be fine. Sprite index. Just carry the loop. Loop comes back to here. Let sprite order come at X. Okay, I'm going to put a breakpoint in there in the debugger just so we can see that it is indeed following that list. So this is our list here. Our routine is not that one. Where is our routine? Our routine seems to be around about here. OB seems to be an awful long way down for some reason. Let me put a sometimes, you know, I was worried about doing this one because I knew it was going to be a tricky one to do. I knew, oh god, fail. If you touch that while it's loading up, you fail. It crashes. I knew it was going to be a difficult thing to demonstrate on stream. I'm actually pleased I've got it this far, to be honest. Hi Cole, welcome to the stream, dude. Okay, so what did it say? OABA. So this is our interrupt code here, which seems to be going crazy. I was going crazy because we're updating these values here. So this is our current sprite index. This is our ordered index. So let's put a breakpoint in there. So our accumulator says our ordered index is 8, but our sprite index is 0. So our first one in this list should be 8 if it's correct. 54, yeah, okay. And now it says it's number 1, 7, yeah, so 8, 7, 9. So it should be just be going through these 8, 7, 9, 6, A, 5. Yeah, it's following this list perfectly, so that seems to be fine, but it doesn't seem to be setting the rasters up correctly now. So let's put another another border increment in here. Just to make sure that our to make sure that our sort routine isn't hanging over into the next. So this is our sort routine. It's happening fairly quickly, so that's pretty good. Are we working up the list or down the list? Well, let's check those values actually. So let's run it in the debugger again. So if our sprite order is at 54, then this is 44, 34, 24. So let's make sure that the order matches in here, make sure it is actually sorted right. It is sorting the list definitely, but let's make sure it's actually sorting it correctly. So according to this, our first sprite is sprite 5. What did I say? 24. So 14. No, 4. 14. 24. Yeah. Our first sprite is 5, and that does seem. No, see, that isn't the lowest. This is the lowest. 0, 1, 2, 3, 4. Oh no, that is right, yeah. That is the lowest one. Okay, 5, that's correct. Then this one. And then 4, this one. It definitely seems to be ordering them correctly. Okay. Let's make sure that after our sort routine we're doing the right things. So we jump to the sort routine. this should all be fine. Is the interrupt set via the index? No, the interrupt should still be set via via this sprite order here. So it's the first thing it does is when this loop begins, it takes whatever the value is in X and grabs the sprite order. But it does look like it's doing it incorrectly for some reason. Sprite Y. Ah, yes. No, you are correct. You are correct indeed. So, actually, this needs to be this again. Thank you, Andy. Lifesaver. Yeah, so we were incrementing the index here and then immediately using it to grab the sprite Y, which is incorrect. So that should hopefully sort that. There we go. So it's a little bit flickery, but it's definitely working there. So we can probably reduce that flickering by playing around with the padding a little bit. So let's have a go at that. Padding is at 2. Yeah, that's quite low. So I think a padding of 4 might sort this out. Not quite. Why is it flickering? Let's have a look at this. Oh, we're getting at least one sprite that's copied on top of itself because it's going around that index. So let's change. Where was it? This to sprites +1. That's going to help so there's not too overlapping. There'd be a complete circle now. But we're still getting some missing sprites somewhere for some reason. And some freaking out. So let's pause it at some point. So it's drawing... I think it's just a padding issue. I think maybe if I change the padding it will be fine. I think it's just because our routine is really inefficient, so this padding needs to be quite high. No, still not. Still not. Okay. Just going to try a ridiculously high value. Yeah, this is not good. Okay, there is an error here somewhere. Let's have a look. So we draw. Yeah, this should be fine. It's definitely. I mean, it's definitely possible to draw this. I've done it before. In fact, I did it on one of my streams, didn't I? I had one of the intros was that, I believe. So you can see it's drawing those on one frame. It's just missing some out now and again. Let me have a look at something. I'm going to actually cheat a little bit and have a look at the cadaver site, because I know he did. I remember seeing something about the position. Maybe it wasn't this page actually, I might have a different page. Position of the next raster interrupts. Okay, let's try messing with that next raster interrupt. So that is this bit. Hang on, is that right? Yeah. Oh, do you know what it is? It's because now that is wrong. Because we're now using this sprite order, we have to keep making sure we're using the right index value here, or else it's gonna fail. There we go, that's better. Cool, right, on that note, I am going to go for a quick cigarette, and when I come back we'll try and we'll put the MSB and I'll show you how to do that, and we'll see how many sprites we can squeeze in before it starts freaking out. So I'll be right back in 2 minutes, guys. Be right back. Alright, I'm back. Don't shoot the snowman. Thank you for the follow, Keno Not. Okay, so just before we do the MSB, I just want to mention some notes on this. So one thing to bear in mind when you're doing this is if you do have more than 8 sprites close together enough that it can't render them, what will happen, in fact I can show you if we just reduce the period between those things in the loop. So if I change this down to like 40 or something, you'll see the problem. They'll start flickering like crazy when they reach certain points and doing that sort of thing. That's because what's happening is when it tries to draw, it draws 8, and then when it does the next raster, it's actually in the wrong place, and you get things cut off. In some cases you'll get flickers and things like that. So it's important that you bear that in mind when you do a multiplexer, that there are limitations on it. Now you can work around them a little bit. So what some multiplexers do is they will only draw 8 sprites in a particular raster, and then from that point on they will stop drawing any more sprites and ignore any sprites that fall inside that raster, and just ignore them completely. They'll still process them that they're in the list, but they'll skip past them. And more advanced multiplexers will even toggle between sets of sprites. So say you've got 16 sprites in the same band, obviously you can only draw 8, so it will draw the first 8 on one frame, the second 8 on another frame, and it will just keep alternating between the two. Generally though, you probably won't need to do that unless you're doing some really crazy heavy bullet hell sort of thing. You can just draw 8 sprites on one frame, and for 50 frames you get 4. Yeah. So I actually didn't need that +1. I don't know why I did that. Okay, so let's add MSB into this as well. So let's start increasing the oh, actually, I forgot that circle pattern. It's not going to be that easy to do. What I'm going to do, I'm just going to move everything over into the MSB. So this is actually only going to display half of the sprites as they turn on one side of the screen, but I want to show you how to actually make that work. So we've got another value that we need to add. We need to do it somewhere around here. Now the way I tend to do this is I'll have 2 lookup tables. So I have my powers of 2 on my pot table and my inverse powers of 2, and this contains 16, 32, 64, 128, and then this one is the basically 255 minus those. So it's 254, 252, 251, 248, 240, 224, 192, and 127. Sorry, 255 minus these, not 255 minus those, so 253. So 255, 255, 255, 255, 255, yep, okay. Again, you can do this more efficiently. You can pre-calculate these ahead of time in your sort routine if you really want to. One way to do the sort routine is when you've, and I do this in Parasol Stars, is when you finish the sort routine, is then you work out where the rasters are. So you don't do any of this crap in here. You just do it. You pre-calculate all ahead of time, and you have another value in your table which just says which raster this is on. If the raster is the same as the last one, you just keep drawing, and the moment the raster changes to a different value, you exit and set the raster up for the next one. You can do the same with the value in D010 as well to handle the MSB. Yep. So I'm going to load the Sprite MSB for that. I'm going to transfer it to X. Actually, I'm going to transfer it to... Do you know what? I'm going to think about this. Yeah, I'm going to transfer the Y value and just push it onto that. Again, this is really inefficient. You probably want to do this in a different way. I'm going to get rid of that because I don't need that anymore. I'm going to transfer that to Y. Then I'm going to load up if it's 0, then I'll jump to no MSB, and this will be MSB. Again, this, as I say, this is really inefficient. You should probably, if you're going to do a multiplex, you should spend some time making these much more efficient than this. So if there is an MSB, we need to get the value in D010, and we just need to turn on that value. So we'll OR it with the value in the power of 2 table, comma Y, because we've got no, not comma Y, sorry, comma, oh shit, we do need comma Y, fuck. So we do need this value here, so it's actually X value we need to store. So, oh god, how am I going to do this now? In fact, I can just store this in temp because that's temp's not being used. So there we go. Right. So we'll keep Y and then transfer Y to the accumulator there, and we need to load X from temp back there again. There we go. Right. Yep, store that in D010. This is such a nasty thing. I'll tell you another tip in a minute about how you can make this much quicker as well. MSB done, yes. If there is no MSB, then we need to do the opposite, which is AND it with the inverse pot of that value and store it there. So this is just flicking one bit on, and this is flicking one bit off, depending on whether it's set or not. Hopefully that all runs now. No, what have I done? Sprite MSB. Did I call it Sprite MSB? I did call it Sprite. I call it Sprite X MSB. Oh, of course I did. So there you go then. So over this side, I mean, obviously you'd have them kind of bouncing around the screen or whatever you do, but that's how you would set it there. And then if I set, if I just set some of them to 1 and some of them to 0, there we go. There's a little bit of flickering going on there. I'm not entirely sure why. Not sure why that's happening. They don't flicker if they're all on 0. It could just be, again, this loop is getting, yeah, they're still flickering. I reckon if I change the padding, that'll fix that. They're getting so, this routine's getting so slow that it's starting to kind of need more and more padding as you go along. There you go. So the more complex that loop gets, basically the bigger the thicker these raster lines get, the more padding you're going to need between them. The more padding you have between them, then the more chance you've got of them flickering when they become really close. But with this in place now, we should just be able to up the number of sprites and hopefully get a few more on screen. So let's try with 24 sprites. There we go. I don't know why it's not filling that gap in there. Maybe it's just a division error. Let's see if we can get to 32. 32 is probably going to start flickering, I think. Yeah, it's flickering a little bit down here. So 32 is probably about the limit of this routine. And you can tell because these lines are really thick now. So trying to process that many is going to cause issues. But you can see the sort routine is pretty efficient. I did have trouble trying to get anything more efficient than that routine. But let's put it down to 28. Again, you can play around with the padding value, the maximum number of sprites, and find a value that works for you. So there's a bit of flickering down there. Let's try just upping the padding a little bit. It's got rid of most of it. You do see the odd glitch here and there. You see the little glitch, and this is what was happening in and up here as well, actually. This is what was happening in creatures when the sprites were being drawn too soon. But generally, I mean, you can probably get away with 16 sprites in most games. 20 is still a decent number. And that's fairly decent. I mean, there's no glitching on that. So one of the reasons this is so slow is because we've got a lot of this kind of $X, $Y stuff going on. There's a lot of indexed addressing going on, and these generally they just add one cycle to each instruction. But if you count that over the course of this loop, it becomes a problem. So what you can do instead, you can use unrolled code instead. And you unroll the loop for all the sprites. So now you don't need this value here, because you would just be copying this basically. You would still need this. You would still need your sprite index. You'll still need to grab the sprite order. But then things like this, so like the sprite color would be D027 plus I. So you're no longer using index and you're using this. And the only thing you have to do is when you do. When you come into this, you need to jump to the correct place in this loop. So what you can do, if you call this unrolled, and you've probably not seen this yet in Kick Assembler, but what you can do is you can jump to a position in that loop, and so you can do like that, and it will skip the first iteration and jump straight into the second one. Now you would have to have a lookup table for this. In fact, let's try and implement that. We've got enough time. I think we can give it a go. So let's take all the code we've got in here. It's set for finish, so finish is fine. We'll keep this in place. So it's kind of all of this stuff here. I'm going to leave it in place. I'm just going to copy it in, and I'm just going to comment this block out instead, and we'll try and make it work inside this loop. And you'll see why it's better. So we still need to grab a sprite index. That's correct. We still need to grab the sprite order. So we'll leave this chunk as it is now. We don't need to grab this anymore because that is this value here. So we can get rid of that. So there we go. That's what, 8 cycles gone straight away from this loop. We do need to do this, and we do need to do this. So any X's we do need to keep in place. But we don't need to use Y. We can use plus I, which is 4 cycles versus 5 cycles. Actually, I think storing is still 4 cycles unless it crosses a page boundary, in which it's 5. Again, here this becomes much simpler. We'll keep that there. We do need to grab the MSB, but now we don't need to do this lookup at all. We can just put the value straight in here. So we can use plus I. Plus I, like so. Transfer Y to the accumulator. We don't need to do that, which means we don't need to double it, which means this just becomes plus I times 2 with no Y. Let's becomes plus I times 2 with no comma y. We don't need to increment the Vic Sprite index, so that's 6 cycles saved there. We do need to increment this one. We keep that in there because we've branched if finish here. And we just need to change this a little bit as well. So we will move this piece of code out and we'll call this next raster. We will read the order, we will grab the sprite, we will compare it, and this time we will do this, jump to this location, which is just going to do the next step in the loop. Otherwise we're going to jump to next raster. So in itself this isn't going to work because this is always going to start at sprite 0. But what we can do is we can create a little lookup table. So we call this actually we do need to keep the Vic index. We do need to increment that Vic index as we go along, so we do need to keep that line in. Which was, let's make sure I put it in the right place. Max Sprite, so it needs to be there, right. So we'll call this not IRQ table, we'll call it a Vic Sprite table, something, doesn't really matter what we call it. And in here we use words and we just point to this loop. So this is IRQ unrolled, which is the loop, 0. That points to the first one. Now you just need 1 for every sprite. Probably do this in a loop as well. There's no need to do it like this, but I am going to do it like that just so it's obvious what's going on. And now we have a jump table. And so now we can just go load Vic Sprite index. I'm going to align this to 100. And I'm going to double that sprite index. And I'm going to store that at the self mod +1. This is our self mod. And this is going to have an indirect jump to the Vic Sprite table. So what's going to happen here is it's going to get whatever the sprite index is, it's going to double it, which is going to point to one of these. Yep, so it's going to point to yeah, it's going to point to one of these because it starts at, say this starts at 0100, then this is 0100, this is 0102, 0104, 0106. This is pointing to the beginning of it. So when we double this value and store it in the MSB here, so this will be in memory, this will look something like, I can't remember what jump instruction is, I think it's like 60 or something. So it'd be in memory, it'll look like 600001, just pointing to this table or wherever this is in memory. But the important thing is this will be 00. When we change this value, we double it, and we store it in this location. This now becomes 00, 02, 04, 06, and so on. Which is basically just jumping into the correct point of this loop. The only other thing we need to do is if we get to the end of this loop here, we need to make sure that we jump back to the beginning again. We just need to keep going through this loop until one of these things takes it out, either the next raster here or the finish here. So I'm hoping this works. Can't get a double representation from a value of type scope. What? Oh, do I have to put that inside? Maybe it should be inside like this. Hang on. Yeah, there we go. That's has to be inside the loop for it to work. And that now needs to be unrolled 0. Oh, why is it failing? Unknown symbol unrolled 0. That should be fine. Why is that not working? Well, I can just put I'm sure that should work though. That feels a bit odd that that's not worked. That should work. How do the loops work now? It's only valid in the for loop. No, it should be. You should be able to reference it from outside. But yeah, that's for some reason that isn't working. Scope error. Yeah, I'm trying to think now at how. This should definitely work though. Let me just indent that so it's a bit easier to read. Keep that one back. Just Andy, he's a mod. He is a mod. Yeah. I can't change the pot with my. Yes, I can. You're right. Actually, I'm going to do that now. Thank you, Andy. This is why I need a. This is why I need a little chat channel just for this. Where did I do that? There we go. So this would be. I think I have to do pow here. 2, I. And that would be immediate. And this would be 255 minus. I'm going to put that in brackets just in case. I don't trust the bracket class in there. Never trust me. I'm doing. No, that's a good one. I'm just wondering why these loops aren't working. Let me just double check on the kick assembler docs. I'm pretty sure that's the right way to do it. I'm being a bit slow with my drink as well. Okay, I've definitely done this for label scopes accessing local labels of for loops. Oh, okay. Oh god, okay. It's more than I remember. So it would be loop start dot unrolled. Oh my god. Why isn't that working? Is it that? There we go. Go. Relative address is illegal. Oh, okay, yeah. The other problem we've got here now is that obviously this loop unrolled, so branches that jump outside of this loop are probably going to be too far away. I heard that actually. There we go. Oh, and it's all gone completely pear-shaped now. Let's try and figure out what's going on there. So it would jump into this loop through this fixed sprite table. Just an indirect jump into here, so it should jump into one of these. This should go through. It's increasing that. It's increasing something at the wrong point for some reason. The border color's going crazy, and it shouldn't be doing that. This is the border color. Decrease there. Oh, okay. That's because. Oh no, that should be fine. Increase border color into here. Go through this. Jump to the loop start again. Yep. Next raster, accumulator set, yeah. Zero 100 is the stats base, yeah, but it's not actually in 0 100, it's just aligned with 100, so this just means in memory it's going to be, you'll see if I do it just ensures that this starts at something something 0 0. As you see there, 0 0 B 0, which I'm actually going to go and have a look at, because it seems like something weird is going on there. It's definitely not running correctly. Where's my monitor? B100. That seems to be pointing into the loop properly, so that seems to be alright. It doesn't seem to be organising any of these sprites, so maybe it's not getting to this part correctly, which is the finish, and that is here. Reload X with sprite index yet, compared to max sprites yet. That's very important to finish. Clear, yeah. So you grab the sprite index, grab our order, set the pointer and the colour, store the X again, and then we get the MSB. Do this. We don't actually need to store the X here at all because we're not destroying it. I don't think. No, we're not destroying it. Okay. Take our sprite positions, set them up, increment the Vic sprite index. Increment the Vic sprite index. Okay, that's because what we're doing is we're not adding that value here. So the sprite index was going past 7. Yeah, there we go. We've got the same thing. But now, because it's on rolled loops, we might be able to get the padding down a little bit now. So let's try reducing the padding to 3. Still a bit of flicker, but I reckon 4 should probably be alright. Yeah, there we go. So we managed to get the padding down to 4 now, which means we could probably add a few more sprites in as well. So if we try 32 again, up the padding to deal with 32. No, we've still got issues with that. Let's try putting the padding back to 4 with 32. It's almost there. It's almost there. Let's up the padding to 5. It's not quite tight enough to do 32. Let's try 28. Yeah, that's pretty good. I mean, obviously the sprite priorities are changing as it goes through the list, so they do appear in front and behind each other. You can implement that as well in your multiplexer if you want to, but that obviously adds some complexity, because then you need to make sure that if there's multiple sprites in a raster, you always give you kind of mark some sprite priorities, so you make sure that the ones with the higher priorities are always the lower numbered sprites. It's difficult to get right, but to be honest, for the most part, you're probably not going to need it. Sprites are going to collide with each other before they overlap. Either you're going to prevent them from actually overlapping through some sort of collision, or you're going to have a death routine, or you're going to have something anyway. But there you go. And you can play around with the sign in here as well. So if you change this sign routine a little bit, so if you make it so instead of a circle you do 3 circles for the X, you can create different patterns as well. So if you do it with 2, it's probably a bit easier. There you go. So that's 28 sprites multiplex. That's not bad actually. I'm pleased we managed to do it. Oh, thank you for the bits, Andy. I missed that completely. Thank you for that. I appreciate it. I really need to figure out how to do my alerts, so I might look into this Streamlabs alerts or whatever it is, which is what I was using when I was using Streamlabs OBS. So I'm hoping I can get all my videos. I think I've saved all the videos for the alerts. Maybe I'll make some new ones. Cool. That's kind of it, guys, to be honest. I might show off my game a little bit, actually. Show you where I'm at with that. Andy gave the missing bits to make the sprites work. Yeah. Andy's been very helpful tonight. This is why I definitely do need a techie room, like a discussion room, so it doesn't get lost in all the stuff. But yeah, one of the most useful things in this is using these loops in this way. So being able to unroll a loop, but being able to jump to any point in that loop using this kick assembler syntax. I mean, you could do it in other ways as well, but this is kind of headphone on Andy's desk. Yeah, this is kind of the way to do it in kick assembler. There's a lot of room for optimization in here as well. The order that you do these things. Oh, hello. Let's say hello on camera. Hello to everyone. Hello. Yeah, you want to sit that way. The order that you do things in that loop has a massive impact on how things work. This is why we do the Sprite X and the Sprite Y last. I'm gonna purr. No. She's purring, but I don't know if you can hear it. There you go in. Really? Just want to sit on my arm. Okay. Shameless stream copying. She just likes to have a look, don't you? Now and again. Is that you gonna sit on? Okay, apparently she's sitting there now. Yeah. So and also you can add more stuff in here as well. So you might want to add double height sprites, for instance. You could have some double height or double width. You might want to have multicolor and high res in as well. I think what else you might want in there. I think that's about it, isn't it, for sprite properties? I don't think there's many more in there. Are you happy there? Yeah. It's purring in my ear hole. Shameless stream copying, yeah. Okay. So I will put this all on the GitHub afterwards. I'm going to leave this commented code in because it might be useful for you guys to look at. As I say, it's not the neatest thing in the world. It's definitely not the most efficient thing in the world. I'm pretty sure if you spend a bit of time, you could tighten this up a lot more. I'm pretty sure this area here, for instance, this comparing the line with the. Oh, yes, that's my. This is really uncomfortable. I'm sure you're happy there, but it's kind of uncomfortable. You're going to go over there. Okay, you sit in your box. Oh dear, Hayes. Oh dear. Okay, I am going to quickly show you where I'm at with the game as well. Just because I think it's been an interesting project for me, actually. So I started drawing up a decision tree, if I can find it. If it loads up. Yeah, so I started making this decision tree. So this is a very, very early step of it for the AI. It's been moved around and kind of adjusted, and there's loads more stuff to go in. So there's no blocking, there's no special moves, there's no reaction to which power up they've picked. There are kind of dumb, and so a red decision here means it's a bad decision. The answer is yes from the option, but it's the bad decision to make. I'll explain that in a second. And a green one means it's a good decision, and a black one means it's just neutral. There is no good or bad. So what I've done is in my AI, I now have this this decision class. And so what this does, the first thing it does is it grabs the stats. This only happens once the player's reaction time ticker is counted down. So as soon as the reaction time ticker counts down, it grabs all this information and it stores it in a few places which are used to make decisions. And then I just have these little blocks basically. So I have a start, which just is the entry point. So in this case it's decision 4 on the tree, which is here. It's the player underneath the opponent. These are my outcomes and what they do, so quite simple. And then my decisions are all just tiny little blocks like this, tiny little compares that just do one little thing and then jump to the next thing. And in the middle of there's a macro which makes a smart decision. So a make a smart decision is when there are two outcomes with the same answer to the question, but two different outcomes. So if you're aligned for an uppercut, then the right thing to do is do an uppercut. The wrong thing to do would be to walk forward. So the smart decision is an uppercut. The incorrect decision is walk forward. And so you'll see in here I have under number 5, make a smart decision, walk forward, outcome uppercut. In fact, that's the wrong way around. It should be good, bad, I think. Hang on. Yes, that should be that way around. That's incorrect. Okay, so that's good. Fixed the bug already. So this is the good decision, and this is the bad decision. And so that looks like, I'll find the file. No, the game will never read your input. So the only thing that the opponent can do is look at where you are on the screen, where the power-ups are on the screen, how much health you've got, how much power you've got for your special ability, what your last move was, what your last move that hit him was, what your last move that they blocked was, and something else as well. Oh, whether or not you're on the ground, in the air, on the player, just like your kind of your position in the world, and whether or not you can jump and that sort of thing. And the enemy only ever uses the joystick to control. There's no kind of sneaky manipulation of the player other than through the joystick. So but I'm quite pleased with this because I did a nice effect for the I guess I'm calling it the space level, but it's not really a space level. Actually, I'm just going to let them fight. Hopefully it picks. If it doesn't pick the space level, I'll restart. So it's got a proper demo mode in it now. So I added this nice effect to make it feel like you're moving along. But they do kind of just about fight each other now. There's a few glitches with the impact animation, and the power-ups don't do anything yet. But you can like super punch people off the screen and stuff, which is kind of cool. And you will shoot right off the top of the screen if you get that. So if you happen to jump up at exactly the same time as you get uppercutted, you get launched super high on the screen. I need to tone it down, it's a bit over the top at the moment, but it kind of works alright. Is that city blocks in the background? It is on this one. On that other level, I'm not sure what it is. I just wanted some animation in the background. I wasn't happy with it, how static it looked. It's kind of feeling good now. The AI is actually quite hard to beat as well, and it's not even blocking yet. I'm thinking it's going to be quite hard once it can block. It's also dumb in some cases, but yeah, it's going well. I'm kind of enjoying it. I'm trying to get it done by the end of this month, although we are cutting it a bit fine now. I've still got a few things I need to add to it, but yeah, I kind of wanted it to feel like a spaceship at first, hence all the stars. But then I realised when I did this, it feels more like you're on a train. Maybe it could add city lights in the windows. So the interesting thing is the way this is working is quite sneaky. This is it's only ever drawing one line of black and dissolving one line of black on the other side, and it's only using colour ramp. There's no actual char shift in there at all. It's just using well, actually no, it's using screen RAM, but to do colour stuff. So But yeah, it's coming along well. I think I'm going to get all the sound effects in it soon, so it's going to feel a little bit better and get the power-ups working. So there's a reason for getting the power-ups. And at the moment, the health bars don't do anything; they just empty and then restart again. There's no reset between the demo. These power bars don't do anything either. But yeah, that's that. I thought I'd show you that. I'm quite happy with that at the moment. And this is the very start of the decision tree. It's going to get a lot bigger than this. I know it is. As I say, I've not got any other power-up abilities in here. None of the special abilities as well. So every special ability for each player is going to be different. No, there are no shooty power-ups. There is potion, which fills up your special bar quicker. So it just gives you like two notches in your special bar. You generate specials by either blocking an attack or hitting the opponent without them blocking. So anytime you do a move successfully, so you make a hit, you block a hit, you gain one little notch in your bar. When you get 8 of them, you can do a special. The potion, if you pick it up, will give you 2 notches, so it's a quick way of building that bar up. There's going to be a health pickup, a bomb, which is just going to basically shake the screen and knock the other player over, and shoes, which are going to give you speed, which if the other player is trying to run away from you, is going to be useful. Likewise, if you want to chase after the, if you want to get away from the other player, then having shoes would be a good thing to have. I think that's pretty much it, guys. I can't think of anything else I need to cover that we haven't already done. Again, if anybody has got any questions about this, I'm on Discord all the time. Please feel free to ask. There's plenty of people on there that have done multiplexers as well. This is, like I say, it's probably only my 3rd or 4th time of writing a multiplexer, so I'm quite pleased I managed to do it in one sitting, to be honest. And it seems fairly efficient. I mean, it obviously could be more efficient, but it's not bad. Again, the thing with multiplexes is look at the amount of raster time this is taking up. So really, a multiplexer is only useful if you can spare that much raster time. I mean, yes, you will do a lot of your scrolling and stuff in the borders, but you still need space for logic as well. So you've got to be careful how much you use it. I try not to rely on them if I can, and if I do need to rely on them, I'll try and use one of the other approaches that we touched on at the beginning. For instance, boss fights. You no need to use a general multiplexer for boss fight. You're better off using the stack sprite method, and then you've got loads of room left over for doing like cool sequences for the bosses. And again, for platformers as well, if you can, try and use the zoned version, because while it's not as flexible as a general multiplexer, with a bit of design you can still make it work almost seamlessly. You won't notice any problems, and you'll have a lot more raster time left over. I mean, this is how many? This is 28, isn't it? 28 sprites. I'd say most sprite multiplexers probably don't need to go above 16. But even then, if you look at the raster time, you've still got a lot being taken up here. Alright, it's a lot less than it was with 28, but you are still using a bit of raster time. And the other problem you've got as well is if you've got another raster effect that you want to do, so say you want to change the colour of the background halfway down the screen, you've now got to add that into the sorting algorithm to make sure it gets fired at the right time, because otherwise it might get missed and you'll end up with flickering backgrounds or flickering sprites, or in the worst case both. So you have to be careful how you use them. Use them sparingly and use them to the limits that you need, and no more. Okay, on that note, I think we'll go and raid somebody. See who we've got going on. Zork's on actually. How do you guess Sarah is doing it? Oh, she's using a sprite multiplexer, absolutely. There's far too much stuff going on vertically for her to not be using a sprite multiplexer. In fact, I think she's touched on the fact she used sprite multiplexer in a blog anyway. So, okay, let's raid Zork. So let me just put my volume on a bit lower so I can actually get it and find. Can I actually? I can raid from here, can't I? See, I still don't know how to bloody do these things. Zork. Zork and Pinner. Cool. Yeah, thanks a lot, guys, for coming along. I'll stick the code for this on the GitHub straight after this, so you can have a play around with it. And I'd be interested to see if anybody does use this, what sort of stuff you come up with. Cool. Right, let's get the raid going. And we'll be back on Saturday for the normal... What is the cat doing there? The cat's decided to climb my units at the back. We were doing the normal game stream on Saturday. I've got some ideas what we're going to do. I'll announce it a bit closer to the time, but yeah. Okay, thanks guys, and see you on Saturday.
It shakes the screen and pauses everything and makes sure you're aware of the